Alright, just testing my mic here. You know what? That sounds way better than what we had yesterday. Time to do a test with the video included. Oh, my desktop audio was muted, hence I couldn't hear it.
Cover off,
and popular course creator. So enjoy the course and don't watch the whole thing in one sitting.
Hello, welcome to the video. It's quite a big one. But if you've come here to learn machine learning, deep learning, and Pytorch code, well, you're in the right place.
Alright, let's see what my audio looks like.
Video and tutorial is
alongside.
focused for beginners who have got about 3 to 6 months of Python coding experience. So we're going to cover
Okay, that
a
is
whole
way
bunch of
better.
important machine
That
learning
is
concepts
way better.
by writing Pytorch code. Now, if you get stuck, you can leave a comment below or post on the course GitHub discussions page. And on GitHub is where you'll be able to find all the materials that we cover, as well as on learnpytorch.io.
But I increase the
There's an
desktop audio a
online
bit now.
readable book version of this course there. But if you finish this video and you find that, hey, I would still like to learn more Pytorch. I mean, you can't really cover all of Pytorch
Alright,
in a
let's
day.
see
That
if
video
you can
title's
hear
just a
on top
play
of
on
my
words of
voice.
the length of the video. That's an aside. There is 5 more chapters available at learnpytorch.io covering everything.
Make it
for
25.
learning,
That should
to
be
model
good for
deployment,
today, and
to
we'll test
experiment tracking,
with that config.
and all the videos to go with those are available at zerotomastery.io. But that's enough from me. Happy machine learning, and I'll see you inside. Hello, my name's Daniel, and welcome to the Deep Learning with Pytorch course. Now, that was too good not to watch twice. Welcome to the Deep Learning with how cool's that fire? Pytorch course. So this is very exciting. You're going to see that animation quite a bit because, I mean, it's fun, and Pytorch's symbol is a flame because of torch. But let's get into it. So naturally, if you've come to this course, you might have already researched what is deep learning, but we're going to cover it quite briefly and just in the sense of how much you need to know for this course, because we're going to be more focused on, rather than just definitions, we're going to be focused on getting practical and seeing things happen. So if we define what machine learning is, because as we'll see in a second, deep learning is a subset of machine learning. Machine learning is turning things, data, which can be almost anything, images, text, tables of numbers, video, audio files.
Let me mute this. And there we go. We are finally live. And it's a brand new day, and we're gonna learn so many new things now. And I'm really excited for today. You might be wondering what's up with the new angle and the new voice settings. I'm just experimenting with new new things as such to see how further I can improve my stream and videos. The angle looks a bit tilted, so I'm just gonna adjust it a bit. That should be good to go for now, and let us begin.
Almost anything can be classified as data into numbers, so computers love numbers, and then finding patterns.
Alright,
in
let
those
me
numbers.
go
Now,
to the segment where we left
how do you
off
find those
yesterday,
patterns?
which
Well,
was
the
at
computer does this part, specifically a machine learning algorithm or a deep learning algorithm.
yeah, we were about to begin computer vision, so we finally let me just pause this. So we finally finished we built 3 type of models: a linear regression model, and then a binary classification model, and then we finally finished a multi-class classification model yesterday. And now we're going to be introduced to computer vision as such. So I say let's begin with it. And Excited to learn new things as always. All right, let's start. Where's the segment? Let's see here. Yep, intro to computer
फोटो यही
vision.
45 5G में मिलता है आपको सेगमेंट्स फास्टेस्ट स्नैपड्रैगन
Let me
6
turn on
जनरेशन
compute,
प्रोसेसर
not
Premium
compute.
or colorful
Let me turn
design
on
with
P8
vegan
mode.
leather finish.
एंड सेगमेंट्स फास्टेस्ट 5G 13 बैंड्स के साथ ऑल दिस मेक्स इट वन ऑफ द बेस्ट 5G स्मार्टफोन्स अंडर 15K.
Hello, Moto.
Hello and welcome back. We've got another section. We've got computer vision and convolutional neural networks with.
We'll probably need another notebook, so let's cut that.
Pytorch. Now, computer vision is one of my favorite deep learning topics.
You know what? For the time being, let's just full screen the video and view it with that.
But before we get into materials, let's answer a very important question, and that is, where can you get help? So, first and foremost is to follow along with the code as best you can. We're going to be writing a whole bunch of Pytorch computer vision code, and remember our motto: if in doubt, run the code. See what the inputs and outputs are of your code, and that's try it yourself. If you need the doc string to read about what the function you're using does, you can press Shift Command and Space in Google Colab, or it might be Control if you're on Windows. Otherwise, if you're still stuck, you can search for the code that you're running. You might come across Stack Overflow or the Pytorch documentation. We've spent a bunch of time in the Pytorch documentation already, and we're going to be referencing a whole bunch in the next module, in section 3 we're up to now. If you go through all of these 4 steps, the next step is to try it again. If in doubt, run the code. And then, of course, if you're still stuck, you can ask a question on the Pytorch Deep Learning repo Discussions tab. Now, if we open this up, we can go New Discussion, and you can write here, Section 03 for the computer vision. My problem is, and then in here, you can write some code. Be sure to format it as best you can. That way it'll help us answer it. And then go, what's happening here? Now, why do I format the code in these backticks here? It's so that it looks like code and that it's easier to read when it's formatted on the GitHub discussion. Then you can select a category. If you have a general chat, an idea, a poll, a Q&A, or a show and tell of something you've made or for what you've learned from the course. For question and answering, you want to put it as Q&A, then you can click Start Discussion, and it'll appear here, and that way they'll be searchable, and we'll be able to help you out. So I'm going to get out of this. And speaking of resources, we've got the Pytorch Deep Learning repo. The links will be where you need the links. All of the code that we're going to write in this section is contained within the Section 3 notebook, Pytorch Computer Vision. Now, this is a beautiful notebook, annotated with heaps of text and images. You can go through this on your own time and use it as a reference to help out. If you get stuck on any of the code we write through the videos, check it out in this notebook, because it's probably here somewhere. And then finally, let's get out of these. If we come to the book version of the course, this is learnpytorch.io. We've got home. This will probably be updated by the time you look at that. But we have Section 03, which is Pytorch Computer Vision. It's got all of the information about what we're going to cover in a book format. And you can, of course, skip ahead to different subtitles, see what we're going to write here. All of the links you need and extra resources will be at learnpytorch.io. And for this section, it's Pytorch Computer Vision. With that being said, speaking of computer vision, you might have the question, what is a computer vision problem? Well, if you can see it.
I think it's about time that I mentioned before I started all of this. I think it was not a year back, but a few months back, I did make a computer vision related program in Python. It's basically it was basically a game. A stone paper scissors game or rock paper scissors game using Python. So you just have your camera and you just choose your option, whether it's a rock paper or scissors by your hands, and then that locks in your option, and the AI just chooses one option at random, and it does stuff. It calculates your points. Basically, in a way, it was related to computer vision. I do remember that we had used, well, I forgot what the name is, but Media Vision, something like that. If you check my previous streams, you would have seen our first trade by Blaze Labs. He was developing something similar with that module Media Labs. Not similar. I'm not sure what he was developing, but my point is, I've already like computer vision was in a way my first real entry into the machine learning field. Yep. That was a bit of story there, and let us continue with the
It can
tutorial.
probably be phrased as some sort of computer vision problem. That's how broad computer vision is. So let's have a few concrete examples. We might have a binary classification problem, such as if we wanted to have 2 different images. Is this photo of steak or pizza? We might build a model that understands what steak looks like in an image. This is a beautiful dish that I cooked, by the way. This is me eating pizza at a cafe with my dad. And so we could have binary classification, one thing or another. And so our machine learning model may take in the pixels of an image and understand the
Seems like Daniel's dad is also optimistic as he is. Just look at him; he's so you know so happy.
different patterns that go into what a steak looks like. And the same thing
Optimistic.
with a pizza. Now, the important thing to note is that we won't actually be telling our model what to learn. It will learn those patterns itself from different example of images. Then we can set things up and have a multi-class classification problem. You're noticing a trend here? We've covered classification before, but classification can be quite broad. It can be across different domains, such as vision or text or audio. But if we were working with multi-class classification for an image problem, we might have, is this a photo of sushi, steak, or pizza? And then we have 3 classes instead of 2. But again, this could be 100 classes, such as what Nutrify uses, which is an app that I'm working on. We go to nutrify.app. This is bare bones at the moment, but right now Nutrify can classify up to 100 different foods. So if you were to upload an image of food, let's give it a try. Nutrify, we'll go into images, And we're going to sample food images. And how about some chicken wings? What does it classify this as? Chicken wings. Beautiful.
Huh. Let's see where that site is up to now. They have updated the site. Utify is free to use with premium features available for $3.99 and $24.99. Made in Brisbane, Australia. Ah, Daniel is from Australia, huh? I thought he was from England or country along those parts. Anyhow, okay, so it's basically an app now. All right, cool. I guess this is a real life scenario of real life use case of machine learning. Now I might download that app myself later on in my own time.
And then if we upload an image of not food, maybe. Let's go to Nitrify. This is on my computer, by the way. You might not have a sample folder set up like this. And then if we upload a photo of a cider truck, what does it say? No food found. Please try another image. So behind the scenes, Nitrify is using the pixels of an image and then running them through a machine learning model and classifying it first whether it's food or not food. And then if it is food, classifying it as what food it is. So right now it works for 100 different foods. So if we have a look at all these, it can classify apples, artichokes, avocados, barbecue sauce. Each of these work at different levels of performance, but that's just something to keep in mind of what you can do. So the whole premise of Nitrify is to upload a photo of food and then learn about the nutrition about it. So let's go back to our keynote. What's another example? Well, we could use computer vision for object detection, where you might answer the question is, where's the thing we're looking for? So, for example, this car here, I caught them on security camera, actually did a hit and run on my new car. It wasn't that much of an expensive car, but I parked it on the street, and this person, the trailer came off the back of their car and hit my car, and then they just picked the trailer up and drove away. But I went to my neighbor's house and had a look at their security footage, and they found this car. So potentially, you could design a machine learning model to find this certain type of car. It was an orange Ute, by the way, but the images were in black and white, to detect to see if it ever recognizes a similar car that comes across the street. And you can go, hey, did you crash into my car the other day? I didn't actually find who it was, so sadly, it was a hit and run. But that's object detection, finding something in an image. And then you might want to find out what are the different sections in this image. So this is a great example at what Apple uses on their devices, iPhones and iPads and whatnot, to segregate or segment the different sections of an image. So person 1, person 2, skin tones, hair, sky, original, and then it enhances each of these sections in different ways. So that's a practice known as computational photography. But the whole premise.
Huh. That's a really cool use case. I didn't know Apple used that. I mean, it sounds believable enough. Hmm. I guess that's how they categorize. Like, I use a Redmi phone here, and it has this feature which I'm sure is also a feature in most phones out there, where they segregate, like they create what's it, a gallery of photos for just a specific person as such. So if you have lots of images with your mother or father in it, or your sister in it, it creates a separate gallery for, and it will name it with first, like your sister's photos, like all the photos which are stored in my what phone which have my sister in it are just in that gallery. If I want to find any picture related to that, I just have to visit that gallery instead. I mean, visit that gallery. um yeah, that's a really, I didn't think of it that it was using machine learning in the back, but yeah, now it makes a lot more sense. Similarly, I guess they use that to enhance our photos. And all right, let's
Premise is
just
how you
continue
segment
with
different portions of an
the
image. And then
video
there's a
here.
blog post here that talks about how it works and what it does and what kind of model it's used. I'll leave that as extracurriculum if you'd like to look into it. So if you have these images, how do you enhance the sky? How do you make the skin tones look how they should? How do you remove the background if you really wanted to? So all of this happens on device. So that's where I got that image from, by the way. Semantic Mars. And this is another great blog, Apple Machine Learning Research. So keep this in mind. We're about to see another example for computer vision, which is Tesla computer vision. A lot of companies have websites, such as Apple, Machine Learning Research, where
Tesla,
they share a whole bunch of what they're
self-driving
doing well
cars and
so in Tesla's case, they have 8 cameras on each of their self-driving cars that fuels their full self-driving data software. And so they use computer vision to understand what's going on in an image and then plan what's going on. So this is 3-dimensional vector space. And what this means is they're basically taking these different viewpoints from the 8 different cameras, feeding them through some form of neural network, and turning the representation of the environment around the car.
before OpenAI and everything boomed, if you had asked me to name a company which uses machine learning, AI related technologies, I would probably have said Tesla, because I think before the rise of LLMs and everything, Tesla was, at least to the normal man, the someone who is not that much involved in tech, knows a bit about tech, would primarily say Tesla as a AI company. I guess in a way it is an AI company, isn't it? most of a car company which uses AI. And yeah, let's
into a
just
vector, so evolve using
continue.
numbers. And why would it do that? Well, because computers understand numbers far more than they understand images. So we might be able to recognize what's happening here, but for a computer to understand it, we have to turn it into vector space. And so if you want to have a look at how Tesla uses computer vision, so this is from Tesla's AI Day video. I'm not going to play it all because it's 3 hours long, but I watched it and I really enjoyed it. So there's some information there. And there's a little tidbit there. If you go to 2 hours and 1 minute 31 seconds of the same video, have a look at what Tesla do. Well, would you look at that? Where have we seen that before? That's some device agnostic code, but with Tesla's custom Dojo chip. So Tesla uses Pytorch. So the exact
Ah, Dojo chip. I've heard of GPUs. Well, I know what GPU is. Of course, I've also heard of TPUs. I think as I mentioned in this video itself, perhaps. Hearing Dojo for the first time.
exact same code that we're writing, Tesla uses similar PyTorch code. So of course, they write PyTorch code to suit their problem, but nonetheless, they use PyTorch code to train their machine learning models that power their self-driving software. So how cool is that? And if you want to have a look at another example, there's plenty of different Tesla self-driving videos. So, we can just play it right here. I was going to click the link. So look, this is what happens. If we have a look in the environment, Tesla, the cameras, understand what's going on here, and then it computes it into this little graphic here on your heads-up display in the car. And it kind of understands, well, I'm getting pretty close to this car, I'm getting pretty close to that car, and then it uses this information about what's happening, this perception, to plan where it should drive next. And I believe here, it ends up going into, it has to stop. Yeah, there we go. Because we've got a stop sign. Look at that. It's perceiving the stop sign. It's got 2 people here. I just saw a car drive past across this street. So that is pretty darn cool. That's just one example of computer vision, one of many. And how would you find out what computer vision can be used for? Here's what I do. What can computer vision be used for? Plenty more resources. So, there we go. 27 most popular computer vision applications in 2022. So we covered a fair bit there. But what are we going to cover specifically with PyTorch code? Well, broadly, my bad. We're going to get a vision dataset to work with using Torch Vision. So PyTorch has a lot of different domain libraries. Torch Vision helps us deal with computer vision problems, and there's existing datasets that we can leverage to play around with computer vision. We're going to have a look at the architecture of a convolutional neural network, also known as a CNN with PyTorch. We're going to look at an end-to-end multi-class image classification problem. So multi-class is what? More than one thing or another. Could be 3 classes, could be 100. We're going to look at steps at modeling with CNNs in PyTorch. So we're going to create a convolutional network with PyTorch. We're going to pick a loss function and optimize it to suit our problem. We're going to train a model, a little bit of a typo there, and then we're going to evaluate a model, right? So we might have typos with our text, but we'll have less typos in the code. And how are we going to do this? Well, we could do it cooks or we could do it chemists. Well, we're going to do a little bit of both. Part art, part science, but since it's a machine learning cooking show, we're going to be cooking up lots of code. So in the next video, we're going to cover the inputs and outputs of a computer vision problem. I'll see you there. So in the last video, we covered what we're going to cover broadly, and we saw some examples of what computer vision problems are. Essentially, anything that you're able to see, you can potentially turn into a computer vision problem, and we're going to be cooking up lots of machine learning, or specifically Pytorch computer vision code. You see, I fixed that typo. Now let's talk about what the inputs and outputs are of a typical computer vision problem. So let's start with a multi-classification example, and say we wanted to take photos of different images of food and recognize what they were. So we're replicating the functionality of Nutrify. So take a photo of food and learn about it. So we might start with a bunch of food images that have a height and width of some sort. So we have width equals 224, height equals 224, and then they have 3 color channels. Why 3? Well, that's because we have a value for red, green, blue. So if we look at this up, if we go red, green, blue,
Everything is RGB these days,
so 24
especially when
RGB
it
images.
comes to
So
gaming.
a lot of images or digital images
I
have
myself
some value
have
for red pixel.
and I don't know if it's, yeah, it is visible, isn't it? An RGB mouse and RGB keyboard from Red Gear here, which I recently found out is a sub company of Bot. And yeah, it's,
A green pixel and a blue pixel. And if you were to convert images into numbers, they get represented by.
let's continue with the tutorial here.
Exactly the same as how we represent these images. So for example, this pixel here might be a little bit more red, a little less blue, and a little less green because it's close to orange. And then we convert that into numbers. So what we're trying to do here, essentially what we're trying to do with all of the data that we have with machine learning is represent it as numbers. So the typical image format to represent an image, because we're using computer vision, so we're trying to figure out what's in an image. The typical way to represent that is in a tensor that has a value for the height, width, and color channels. And so we might numerically encode these, in other words, represent our images as a tensor. And this would be the inputs to our machine learning algorithm. And in many cases, depending on what problem you're working on, an existing algorithm already exists for many of the most popular computer vision problems. And if it doesn't, you can build one. And then you might.
Let's listen to that again.
With machine learning is represent a little less green because it's close to orange. And then we convert that into numbers. So what we're trying to do here is essentially what we're trying to do with all of the data that we have with machine learning is represent it as numbers. So the typical image format to represent an image, because we're using computer vision, so we're trying to figure out what's in an image. The typical way to represent that is in a tensor that has a value for the height, width, and color channels. And so we might numerically encode these, in other words, represent our images as a tensor. And this would be the inputs to our machine learning algorithm. And in many cases, depending on what problem you're working on, an existing algorithm already exists for many of the most popular
Yep. Somehow convert whatever data you're working with, whether that be images or you're into tensors. Okay, the technical term is numerical encoding apparently. Once you have them, you